Yeah, so welcome everybody. So this is a project that Maxim and I have been working together. So it's called MigraineChat, and it is a conversational agent supporting migraine patients in their journey and in their everyday life. And I'm not moving to the next slides. Okay. So for those of you who are maybe not so familiar with migraines, a migraine is actually not like a regular headache, so to say, like we all occasionally get, but in fact, it is a debilitating chronic neurological disorder. So about 14% of people worldwide have migraines, and you can imagine that on average, the intensity that a migraine can have is a medium to severe level of pain. So people that have migraine have these regular episodes, and these episodes can last up to 72 hours. So it's estimated between 4 and 72 hours of pain. And it is estimated that 30% of people with migraine experience at least 4 days of migraine per month, which is quite a bit. And then a smaller subset of them might even experience up to 15 days of migraine pain per month. So you can imagine that can be quite debilitating in your everyday life. So the goal of MigraineChat is to basically to be a conversational agent that supports people that have migraine in their everyday life with three main purposes. So the first one is being to help them log their migraine data, but also other health-related data in their everyday life, and to do this in a rather easy fashion by privileging the vocal modality. Because another characteristic of people with migraine is that they often tend to be sensitive to light. So for them, basically being on a screen and typing in their symptom is actually not the best modality possible. In addition to them, we want to help them get insights about their migraine patterns. And finally, once enough data is collected, we would also like to help them get AI-powered predictions about their next episodes so that they can potentially adapt. So the three basically potential users or beneficiaries, I would say perhaps, of this app are of three types. So the main users will be, of course, the patients who can track their data with that, get predictions about their next migraine, and hopefully also be able to take some form of preventive actions. For example, they can decide to take medication before the attack happens in this full strength, or they can decide maybe to reorganize their day so that it's a bit more compatible with them having a migraine. This, however, can also be interesting for physicians because then they can access not only the subjective reports of the patients, but also some quantitative reports about them. This can be helpful for early diagnosis because, of course, not everybody is diagnosed, unfortunately. And also to adjust, for example, medication or access certain type of medication that is specific to migraine. And then finally, it can also be interesting for research because, of course, it's not like we understand everything about migraine, unfortunately. And so having this kind of larger data collection can also help identify so far undiscovered patterns. So I would like you to show how this vocal logging of the symptoms works. And there's going to be some audio, so let's hope that this works fine.
Hi, I have a migraine today. It's about a 3 out of 4 in intensity. The pain is throbbing and mainly my left temple with some neck stiffness. I, however, did not experience any aura. I took ibuprofen, but it didn't help at all. The migraine started around 2 p.m. and is still ongoing. The pain has affected half of my day, and I unfortunately did have to take sick leave.
So here what is happening is that basically this audio is being sent to the backend, where there's first going to be a speech-to-text translation. Then there's going to be a large language model that will extract structured data from this voice. And finally, there's going to be a text-to-speech translation so that the agent can respond.
Did you have any nausea today? Did you experience light sensitivity, photophobia during the migraine?
I didn't have any nausea today. However, I experienced photophobia. Besides that, my energy level was at 2 out of 4, and my mood was also 2 out of 4. I experienced some issues focusing and some irritability.
So basically, the idea is that here there is a conversation that is ongoing with the agent, and the agent is going to try to complete basically a series of, to collect a series of features. So there's going to be an ongoing conversation in loops like that.
Did you notice any increased yawning today? Did you have any food cravings today?
No, no increased yawning and also no food cravings. And that's all for today from my side.
So basically, as a user, you of course also have the possibility to exit this conversation whenever you wish, so you don't get stuck when you maybe don't have time. And the agent recognizes that and so acknowledges the end of the conversation.
Thank you. Until next time.
Sorry, I hope it was well hearable despite the lag. So in the meantime, what this is doing is that it is basically going to, oopsie. It is going to be, extracting basically JSON-like data from whatever has been going on during the various turns of this conversation. Of course, it's not asking for random things, it's asking for a series of features that we have set it up to ask. How does this work sort of in the backend? So we do have, of course, this front end that is collecting the voice input. It is sending it to our backend where there is a fast API endpoint that is basically sending this back to external services, where we first have this speech-to-text model that will basically take the speech and translate it into written text. Then this is going back to our transcribe API, and it's being first sent to a second endpoint, so the chat endpoint, which then sends it over to OpenAI for extraction, basically, of this structured data from the continuous text. And then this is sent back to the backend again, and then back to the text to speech, and then the speech is being sent back to the user. At the end of a conversation, of course, all the extracted data, as well as the written conversation, is being stored inside the database for logging, essentially.
So this is the front end of our app, and for demonstration purposes, we have generated some synthetic data, so some synthetic users, and so let's log in as synthetic user number 7 and see what we have.
Mm-hmm.
All right, so the chat tab we have just seen, and now let me show you the other tabs that we have here. So here's the tab with the statistics, where here we see a GitHub style yearly heat map of migraine episodes, where the intensity corresponds to the color as usual. And if we scroll down a bit, then we see average duration, average intensity, as well as all information on pain location and pain type. And if you scroll down a bit more, then we come to 2 overlay diagrams where you can, for example, in the first one, overlay, say, your average mood changes around a migraine episode. So, for example, this indicates the beginning of the migraine episode, and we see that the preceding days, the mood on average is going down for this particular patient. All right, now let me also show you one of the other features, namely the tab with predictions. So based on the previous days, today and the previous data from the previous days, we produce a prediction for the migraine onset tomorrow. And so in this case, it's probability 99%. However, like I already said, this is generated data, synthetic generated data for demo purposes. And I'll address this in a later slide in more detail. So in the front end, so our stats tab calls the stats endpoint of our backend, which then in turn fetches data from the database, processes the data, and sends it back to the front end for visualization. in the case of the prediction tab, the endpoint preds is called, which then fetches a trained model exactly for this user. So the model was trained only on the user data, and then an inference is run on this and then shown to the user on the front end. And let me dwell a little bit more on this prediction part. And so what are we predicting? Well, first of all, like I already said, currently we do not have active users yet. However, we wanted to address this future point already now, make some scaffolding, so to say, of how it's going to work. And for this purpose, we generated some synthetic data. And so the task is based on the data of previous days or months to predict the risk of having a migraine tomorrow. So this is a binary classification problem. And our approach to this is to have one model per user. So the model is trained only on the user data. And so we chose two models. So logistic regression as our base model and XGBoost as a more advanced model. Both are well established for tabular data and binary classification, and their advantage is that they are explainable. For example, as opposed to this, say deep learning is not, we decided not to use deep learning due to lack of explainability, but also because we have training on the data of one single user, and we simply will not have enough data even for a real user to train a deep learning model. So as features, we use the features listed here on the slide, and they are a combination of so-called premonitory symptoms and subjective state of the patient. And these are all clinically recognized early warning signals of a migraine. Plus, we also add leg 1 features of these original features. And so we add them for the model to be able to see the yesterday's values, so to say, so to capture short-term build-up trends. So what kind of challenges we face here? Well, our features are time series. And so we have to account for that when training. And so what we do is we do a time-based train test split. So we take 80% of available data for training and 20 for testing. And the second challenge is the class imbalance, as migraine days typically occur only in a minority of days. And so this data set is, any data set of this type for any user will be imbalanced. And so we use class weights during training. And well, as evaluation metrics, I mean, because of this imbalance, accuracy is misleading. And so instead we use precision, recall, and OC-ROC metrics. However, despite the fact that we are achieving good performance on synthetic data, but since it's synthetic data, we are not going to dwell on these metrics further until we have real user data. All right. So let me tell you what we are currently working on. So one of the directions is to polish voice interaction further. By this, I mean to have evaluation data sets, use perhaps LLM as a judge of the quality of the conversation, so to have a score for that. And we are currently using LangFuse for observability. The next direction is to have real users for testing. And for that, we also need to get GDPR compliant. So, for example, to have at least encryption at rest and in transit and these kind of matters. Also, an interesting direction we are currently working on is automated tracking of such features as weather data and data from wearable devices. And finally, we'd like to also have on-the-fly user-specific feature recognition directly from the voice interaction. All right, that's it. Thanks a lot for your attention.